We met it as a giant, C/2025 R2, SWAN, a visitor from the cold, dark frontier of our solar system, with a nucleus larger than almost any we have ever seen. Its colossal size promised a celestial spectacle, a great comet for a new generation. But as this icy mountain falls towards our sun, a new story is emerging. A story that is not about its size, but about its journey. In the precise and predictable clockwork of the solar system, where gravity is king, the path of every object should be a perfect, calculable ellipse. For millennia, we have mastered this celestial mechanic, predicting eclipses to the second and guiding spacecraft to distant worlds with pinpoint accuracy. But the path of C/2025 R2 SWAN is not perfect. There is a flaw in its trajectory, a subtle deviation, a ghost in the orbital mechanics. And when astronomers traced this flawed path back in time, they stumbled upon a coincidence so startling it threatens to connect this ancient visitor to a forgotten mystery of our own sun. To understand the anomaly, we must first understand how we map the heavens. The science of charting the positions and movements of celestial objects is called astrometry. It is the oldest branch of astronomy, yet it remains one of the most fundamental. When a new comet like SWAN is discovered, observatories around the world begin a coordinated campaign. Night after night, they take images, precisely measuring the comet's position relative to the background stars, which are so distant they appear fixed. Each measurement is a single data point, a breadcrumb on the comet's long trail through the solar system. By collecting dozens, then hundreds of these breadcrumbs, astronomers can feed them into powerful computer models. These models are built on Newton's and Einstein's laws of gravity. They account for the immense gravitational pull of the Sun, as well as the smaller but significant pulls of the planets, like Jupiter and Saturn. The computer then calculates the one unique orbital path, a long, stretched-out ellipse that perfectly connects all the observed breadcrumbs. This process gives us the comet's trajectory, allowing us to predict where it will be weeks, months, or even years in the future, and to trace where it has been for millennia in the past. And this is where the mystery began. As more and more data points for C/2025 R2 SWAN were collected, the calculated orbit and the observed orbit did not perfectly match. There was a small but persistent discrepancy. The comet was not quite where it was supposed to be. Now, for comets, this is not entirely unusual. They are not perfect solid rocks. They are active gassy bodies. As a comet nears the sun, its ice sublimates, and jets of gas can erupt from its surface. These jets act like tiny, unpredictable rocket thrusters. They can gently push the comet, causing it to deviate from its purely gravitational path. These are known as non-gravitational forces, and astronomers have sophisticated models to account for them. But for C/2025 R2 SWAN, even after factoring in the most generous models for outgassing based on its size and brightness, the deviation was still there. A small residual error that could not be explained by gravity or by the comet's own jets. Something else was influencing its path. Something was missing from our models. When a comet's path presents a puzzle, astronomers have a powerful tool at their disposal: orbital back integration. If you know an object's current position and velocity, and you understand the laws of gravity, you can calculate where it will be in the future. But you can also run the simulation in reverse to determine, with stunning accuracy, where it came from. Using supercomputers, scientists took the observed path of C/2025 R2 SWAN, including its strange deviation, and traced it backwards. They watched as the comet flew back past the orbit of Jupiter, past Saturn, Uranus, and Neptune. its path stretching out into the vast empty space beyond the planets. The simulation integrated its path backwards for thousands, then tens of thousands of years. The goal was to trace its journey all the way back to its home, to the moment it was first nudged out of its ancient stable orbit and began its long fall towards the Sun. Finding this point of origin could provide clues about what might have influenced its journey. As expected, the simulation traced the comet's origin back to the Oort cloud, that immense theoretical sphere of icy bodies that surrounds our solar system. The computer model could even pinpoint the approximate region within the cloud from which it was likely dislodged millions of years ago, perhaps by the gentle gravitational tug of a passing star. This was standard procedure, a confirmation of the comet's primordial origins. But the team didn't stop there. With an object this unusual, they needed to be thorough. They continued to trace the comet's trajectory, not its physical path millions of years ago, but its geometric path, its straight line of sight through space, even further back into the past. It was a long shot, a search for any possible alignment, any cosmic coincidence that might explain the subtle anomaly in its orbit. And that's when they found it. A coincidence so precise, so unlikely, it sent a ripple of shock through the astronomical community. The coincidence had nothing to do with the Oort cloud. It had to do with our Sun. While running the orbital back integration, a researcher decided to cross-reference the comet's trajectory with the historical record of major solar events. And one event stood out. In the late summer of 1770, astronomers around the world recorded a period of intense and bizarre solar activity. For weeks, the Sun was covered in enormous sunspots, visible to the naked eye through haze or at sunset. Auroras, the northern and southern lights, were seen at latitudes incredibly close to the equator, from southern China to the Caribbean. These are all signs of a massive geomagnetic storm, an event where the Sun blasts a huge cloud of magnetized plasma towards the Earth. This great solar storm of 1770 was a historical mystery. It was far more powerful than the famous Carrington event of 1859, but its cause was unknown. It was a violent, unexplained outburst from our own star. And this was the chilling coincidence. When the computer simulation traced the path of C/2025 R2, SWAN, back to the year 1770, its position in the sky aligned perfectly with the Sun as seen from Earth. More than that, the subtle, unexplained deviation in its orbit, that tiny push that couldn't be explained by outgassing, was pointing directly away from the Sun. It was as if, in 1770, the comet received a powerful shove from the direction of the Sun, a shove that was still subtly affecting its path more than 250 years later. The timeline was a perfect match, the direction was a perfect match. An unexplained anomaly in a comet's orbit was pointing directly to an unexplained anomaly in the Sun's history. It was a 1 in a billion alignment, a cosmic coincidence so profound it could not be ignored. It posed a tantalizing and almost heretical question. Were these two events connected? Could a comet, an icy visitor from the dark, somehow be linked to one of the most violent solar outbursts in recorded history? To understand the coincidence, we must first understand the mystery it points to. The Great Solar Storm of 1770 is a puzzle for solar physicists. Our best record of it comes from the meticulous logs of 18th century astronomers, as well as personal diaries and even ancient Korean court records. For several weeks, they described the Sun's face as being marred by sunspots so enormous they could be seen without a telescope at sunrise and sunset. This was a sign that the Sun's magnetic field was incredibly tangled and stressed. Then came the auroras. Normally confined to the polar regions, the northern and southern lights were seen across the globe. Witnesses in East Asia described, quote, celestial flames, and a sky on fire for 9 consecutive nights. This was not a gentle, shimmering curtain of light. It was a vast, blood-red glow that filled the sky, an event so unusual and terrifying that it was recorded as a divine omen. These low-latitude red auroras are the telltale signature of a geomagnetic storm of almost unimaginable power, far stronger than any we have experienced in the modern industrial era. We now know what causes such an event. A solar storm is triggered by a release of energy from the sun's tangled magnetic field. This can take the form of a solar flare, an intense burst of radiation, or a coronal mass ejection, a CME, which is an enormous eruption of magnetized plasma from the sun's outer atmosphere, the corona. When a CME is aimed at Earth, it can slam into our planet's magnetic field, triggering a geomagnetic storm that produces spectacular auroras. The most famous example in modern history is the Carrington event of 1859. It was powerful enough to set telegraph systems on fire and produce auroras so bright that people could read a newspaper by their light at midnight. The 1770 storm, based on the historical accounts of its duration and reach, is believed to have been significantly more powerful, perhaps one of the strongest of the last millennium. But what could cause such a violent, anomalous outburst from our normally stable star? That remains a mystery. And now, into that mystery, flies a giant comet, on a path that seems inextricably linked to that very event. The perfect alignment between the 1770 solar storm and the trajectory of C/2025 R2 SWAN has led to a fascinating, though highly controversial, hypothesis. What if the two events are not a coincidence, but cause and effect? Could an object impacting the sun trigger a superstorm? For decades, the idea of comet impact solar flares has been on the fringes of solar physics. The theory is that a sufficiently large object plunging through the sun's corona could disrupt its complex magnetic field lines, causing them to snap and reconnect in a violent explosion. A direct impact from an object as large as Comet SWAN would be a cataclysmic event, likely far more powerful than what was observed in 1770. But what if C/2025 R2 SWAN wasn't alone? Comets are often part of a larger family, fragments of a single, giant progenitor that broke apart long ago. Is it possible that a smaller, now vanished sibling of Comet SWAN was the true culprit? Could its suicidal plunge into the sun have been the trigger for the Great Storm? This provides a potential explanation for both mysteries. A smaller, sibling comet causes the 1770 solar storm by impacting the sun. The resulting massive coronal mass ejection then expands out into the solar system and slams into the much larger C/2025 R2 SWAN, which was passing by at the time. The immense blast of plasma and magnetic fields would have given the comet a powerful shove, a non-gravitational push that perfectly explains the subtle deviation in its orbit that we still see today. The comet's path wouldn't be a coincidence. It would be a scar, a lasting injury from a violent solar event. A fascinating story is one thing, but scientific proof is another. How could we possibly test such an extraordinary hypothesis? The evidence may be hidden here on Earth. When a major solar storm hits our planet, it can leave behind chemical traces. High-energy solar particles can create specific isotopes, like beryllium-10 and carbon-14, in our atmosphere. These isotopes then fall to the surface and are preserved in layers of ice in places like Greenland and Antarctica. Scientists are now re-examining ice cores from the 1770s, looking for an unusually strong spike in these isotopes. Finding such a spike would not only confirm the immense power of the 1770 storm, but could also provide clues about its nature. Furthermore, Astronomers are meticulously scanning old astronomical archives. They are looking for any forgotten observations of a faint comet in the years leading up to 1770, one on a trajectory that would have led it directly into the Sun. The puzzle is ancient, but the tools to solve it are modern. The evidence, if it exists, is waiting to be found in the ice and in the archives. The hypothesis connecting Comet SWAN's sibling to the 1770 solar storm, while still speculative, forces us to consider a new model of our solar system. We tend to think of it as a stable, predictable system, where the Sun's gravity and light dictate the behavior of all smaller bodies. But what if the influence can sometimes flow the other way? What if these colossal visitors from the Oort cloud are not just passive spectators, but can, on rare occasions, be active participants in the life of the inner solar system? This idea suggests a more dynamic, and perhaps more violent, reality. A system where a primordial comet, a relic from the formation of the planets, can have a direct and powerful influence on the behavior of our own star. It implies that to fully understand the Sun's history, we must also understand the history of the objects that travel through its domain. The path of C/2025 R2, SWAN, may be the first piece of evidence that connects the deepest, coldest parts of our solar system with the fiery magnetic heart of it. As C/2025 R2, SWAN, continues its journey closer to the Sun, it will become one of the most intensely studied objects in the sky. Solar observatories will monitor our star for any unusual interactions as the comet passes. Planetary scientists will use powerful telescopes like the James Webb Space Telescope to perform detailed spectroscopy on the comet's coma. They will be searching for any unusual chemical signatures, any isotopic ratios that might set it apart from other comets, and hint at a shared origin with the hypothetical 1770 impactor. Astronomers will also be hunting for companions. Does the giant comet have smaller unseen fragments traveling with it? Finding a family of objects along the same strange orbit would lend significant weight to the theory that a now-vanished member of this family was responsible for the solar storm. Every new piece of data gathered over the coming months will be a clue, helping to solve this 250-year-old mystery. So, if you only remember one thing, it's this. The strange path of this giant comet has given us a tantalizing link to our Sun's violent past, suggesting a cosmos that is far more interconnected than we ever imagined. The comet's trajectory has told us a story of where it has been, but as it continues its journey towards the Sun, it's beginning to tell a new story of what is happening to it right now. Something strange is happening to the comet itself. Its brightness is fluctuating in ways astronomers can't explain, hinting that the giant is not just a silent witness, but is an active and unpredictable mystery all on its own.